Woohoo! We are live. This is Math 60 Intermediate Algebra, although this is appropriate for anyone who's doing radicals, work with radicals and powers. And this is a topic that is frequently misunderstood and often considered fairly terrifying. I know I was terrified of this when I first learned it, and I couldn't figure out what the heck was going on. So here I will go ahead and try to explain what the heck is going on. And if it helps, I have a happy little spider. Yay! See, it can't be scary if there's a spider. Okay, so a note about radical x squared. So first thing we're going to do is we're going to simplify. And if I simplify radical or square root or principal square root or positive square root of 2 squared goes first, it becomes 4. We take the square root or the principal square root of 4, and that's 2. Woohoo! Also, I can take radical negative 2 squared. But if I have negative 2 squared inside, negative 2 times negative 2, just as a review, is positive 4. Remember that. Little arrow over there. So we get radical positive 4. Put a box around it. Boxes around things make everything make more sense, right? So there's a positive 4, which also equals 2. And we get the same answer. So the problem with this is that we started out with different values inside these parentheses, either a 2 or a negative 2. And we end up with the same answer, which means that, and I wrote a lot here, you can read through it, regardless of whether we start with 2 or negative 2, radical x squared gives us a positive answer. Squaring x makes it, quote unquote, forget whether we start with a positive or negative 2. So when we write the general rule, when I say in general, when I take radical x squared, I'm not necessarily going to get x out. If I put in negative 2, I got out positive 2. I don't get out negative 2. So we get out the absolute value of x. So that's all that's happening. The squaring makes the math forget whether there was a plus or a minus attached. And it just by default says, let's just give you the positive one, which I think is nice. It's the easier of the two to deal with. So I think it was a good way to go. Nice going, old dead mathematicians. Okay, of course, with cubes and cube roots, this isn't a problem. So let's look through with cubes. 2 cubed is 8, and the cube root of 8 is 2. Okay, 2 goes in, 2 comes out. Negative 2, the quantity cubed, is negative 8. Negative 2 goes in, negative 2 comes out. Cubes preserve the sign of the original number, so we don't need to use absolute value. Woohoo! So when we're working with radicals, if the problem set you're working with specifies that variables can be any real value, or they can take on any real value, or they represent any real value, just remember to use absolute value with even indices. So radical x squared is absolute value of x. The 4th root of x to the 4th is absolute value of x. The 6th root of x to the 6th is absolute value of x. But again, cube root of x cubed is just x. 5th root of x to the 5th is just x, and so on. So when they're odd, there's no absolute value. Because cubing or 5th powering, if it's an odd exponent, it won't destroy the sign. It doesn't get rid of the sign. It's just the even exponents that do. Now, if the problem you're working with specifies that variables only represent positive or non-negative values or something similar, so it's restricting your variables to positives or non-negatives, then you don't have to worry about the absolute values because it won't even come up because negative numbers won't go in. And so that all seems hopefully that seems very clear and everything is good, but dun, 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 dun. That was a little exciting. I'm excited about this. I find it exciting because I finally understand it. Now I inexplicably wrote a 2 there, so let's rewrite this. I'm not sure where that came from. I was just excited about indices. So let's look at what happens if I have radical x to the fourth or square root of x to the fourth. So I am looking at the square root or radical of x squared squared. So I'm squaring x squared. So I'm going to get, right, the square root of something squared is the thing itself. And then everyone will be like, oh, we got to put in the absolute value because it's even, right? Even. So we go for absolute value. Right? Dun, dun, dun! X squared is always positive. So will the absolute value do anything? So dun, dun, dun! We don't write absolute value. And at this point, if you've just thrown everything down on the ground and you're just like, that's it, I'm done with math, I'm going to go into art. I totally understand you, but art is harder than it looks. I'm just going to warn you. You know, math doesn't have long essays. Just also going to point that out. So let me give you an example that I hope will either confuse things further or clear things up. I'm going to go for radical a squared b to the fourth c to the fifth. I can't do c to the fifth, c to the sixth. Let's do it that way. Okay. So, and here at this point, some of you who are seeing this might not know how to work through this. If you're taking a square root, it's basically just half of the exponent. So square root of a squared gives us a. Square root of b to the fourth gives us b squared. Square root of c to the sixth gives us c cubed. Okay, so now who needs absolute value? B squared is always positive. So as long as you're dealing with real numbers, if we're dealing with complex numbers, this is completely different. This all gets very interesting. But as long as it's a real number, this is always positive. A, however, it went and got squared. So let's think it through. If a were negative, a squared is positive, and the square root would be positive. So we need that absolute value to say, if you put a negative number in, you may not get the negative number back out. In fact, you won't get the negative number. You'll get a positive. B squared is already positive. Let's think through the C. If C is, and this is unfortunate because I messed up and I wrote C to the fifth and I realized we couldn't handle that. So it's C to the sixth. So if it's C to the sixth, -1 to the sixth power is negative. Sorry, -6. -1 to the sixth power is positive. Sorry about that. And then when we take the square root, we're going to get another positive. So this one also is an absolute value. And then whether you write the cube inside or outside of your absolute value is kind of, it's up to you. I've seen it in both ways. So it's either the absolute value of c cubed or it's the absolute value of c cubed. But these two require absolute value. And I have even seen it like this. Oop, you can't see that. There's another way to write it. Some people group all the things in absolute value just to get them over with. And some people would put the b squared first. I mean, you've got a lot of options here. But that's how we deal with it. Kind of woohoo. Hopefully that makes sense. Woohoo. Math on.